How does physics apply to our everyday lives? To answer that, we first need to know, what is physics? Well, it's the science that explores the fundamental principles and laws governing the behavior of the universe. Or, in more simple terms, it's the rules of the universe. Physics governs everything, and in this video, I will be explaining 3 concepts that are applied to everyday things. The first concept that I will explain is the concept of projectile motion. Projectile motion is the motion of an object that is launched into the air and moves up under the influence of gravity. It has practical applications in various sports, such as basketball, baseball, and soccer. Take for instance this video of me shooting a basketball free throw. You can calculate the velocity of the shot, which is the speed with a given direction, with a couple of measurements. In my throw, the launch angle was 55 degrees, the distance to the hoop was 5 meters, the acceleration, which is the change of velocity that is caused by gravity, is 9.8 meters per second squared. The time for the ball to land is 4 seconds, and with this we can calculate the velocity of the ball. This equation is broken up into multiple parts. The first part is the initial velocity in the x, which equals distance over time. In this case, it is 5 meters over 4 seconds, which comes to 1.2 meters per second. With this, we can find the initial velocity on the line that the ball is thrown through using the velocity of the x, which equals the velocity times cos theta. And this comes to 2.18 meters per second. And the last velocity we can find is the y directional velocity. This we can use velocity on the thrown line times sine theta, giving 1.79 meters per second. Another concept in physics that is seen on a day-to-day basis is collisions. Whether it's a car accident, a high five, or a game of pool, we see collisions all the time. There are generally 2 types of collisions, elastic and inelastic collisions. An elastic collision is one of which both momentum and kinetic energy are conserved. This means that before and after the collision, the total momentum and total kinetic energy of the system all remain the same. In the inelastic collision, the total kinetic energy is not conserved. Some or all of the initial kinetic energy can be converted into other forms of energy such as heat, sound, or deformation. In an inelastic collision, the objects may stay together or deform upon collision. In this example, the pool ball starts at this point, heads this way, and meets with pool ball 2. When they connect, pool ball 1 veers off at an angle from the normal line of 50 degrees. Pool ball 2 heads off at an angle of 30 degrees. When pool ball 1 is hit, it has 1.5 meters per second in the x direction as its velocity. So with this knowledge, we can actually calculate the speeds of 1 after the collision, which we'll call v1 final, and then 2, which we'll call v2 final. So to do this, first formula would just be v1 initial equals v1 final cos theta plus v2 final cos beta. We know that v1 final is 1.5. Now, since we know the angles, this one is 50 and this one is 30. We can now simplify it even further. Cosine of 50 is about 0.64, and the cosine of 30 is about 0.87. We'll come back to this formula, but for now, we can leave this as our x direction to figure out the y. There's no speed going in the y, so we'll set speed to 0, right? Because it's heading in a straight line on the x. then set that equal to v2 final sine of 30, because it's in the y direction, minus v1 final sine of 50. So with this, we can set it to, since we know sine of 30, 0.5, and then minus 0.77. So with this formula, we can actually now figure out a relation between v2 and v1 final. 0.5 v2 final is equal to 0.77 v1 final. With this, we can now turn this into a just v2 final by multiplying it by 2. We can figure out v2 final equals 1.54. We can now actually sub it back in because we know a v2 final. So this right here can be subbed in for this. So we'll go back to this formula for the x direction. So 1.5 equals 0.64 v1 final plus 0.87 times 1.54 v1 final. So now we have two of the same variables. We can just multiply this through now. That comes to 1.34 v1 final. 1.5 equals 1.98 v1 final. So now we can figure out what v1 final is by just dividing by 1.98. That gets us v1 final equals 0.76 meters per second, and that is going 50 degrees from the normal. So now with this, we can actually find the final velocity of the other ball by using the formula v1 initial squared equals v1 final squared plus v2 final squared. Now, we are assuming an elastic collision, which pool balls are very close to being perfectly elastic. However, there is some friction, so we're just ignoring at this time. So we can actually rearrange this to get v2 final equals the square root of v initial, or v1 initial, minus v1 final. So that equals 1.5 squared minus 0.76 squared, and all rooted. And that gives us a speed 1.3 meters per second, 30 degrees from the x. And yeah, so that's how you calculate collisions. Noise cancellation is based off the principle of destructive interference. Sound waves
In
are
our
essentially
media, we often
variations
see
in
violations of
air
physics
pressure,
concepts.
which
For
happen
instance,
from
in
a
the
result
movie
of
Wanted, the main
vibrations.
characters are
And they
skilled
travel in
assassins who
waves.
possess the ability
These
to curve the
waves
trajectory
exhibit
of bullets by
characteristics
manipulating
such as
their body movements.
amplitude, which
They
is
can make the bullets change
the,
direction mid-fight and accurately hit targets
basically
around
the
corners
center
and behind obstacles.
to
This violates the fundamental
either the top
principles of
or the
projectile
bottom
motion and
is
conservation of
the amplitude,
momentum.
as well as the frequency, which is just how many times a wave happens per second.
How am I supposed to do
When
that?
sound waves
It's not a question
come
of how.
together,
It's a
so
question
let's
of
say
what.
we have this sound wave
If no one told
and
you
this
that
sound
bullets
wave come
flew
together,
straight, and I gave
they
you a gun
combine
and told you to hit the target,
and make
what
another
would you
sound
do?
wave. Now, these sound waves, they're in
Let your
phase,
instincts
meaning
guide you.
their peaks line up with their peaks and their troughs line up with their troughs, which means they'll actually come and be a bigger sound